In the previous videos, we discussed about different types of functions. That means we have discussed about implicit functions, and then we also discussed about inverse trigonometric functions, correct? Now, in this particular video, we are going to understand another type of functions and also how to differentiate that particular type of function. All right. Now, we are going to discuss about exponential functions. So, we are looking at exponential functions. See, when we talk about exponential functions, you need to understand a couple of things. Now, whenever we talk about exponential, you need to understand that the value either increases drastically or decreases drastically. This is the whole point of the word exponential. All right. See, that's why whenever we talk about exponent, something to the power of something, like in the sense you can say a to the power of x. This is an exponent. Like you can say 3 to the power of 5, or you can also say something like 4 to the power of minus 3. These are all exponential functions. An exponential function can be defined as f of x is equal to e to the power of some variable x. Alright. Now, e to the power of x is one type of an exponential function. Alright. Now, e is a particular number. As we all know, e, you have seen e before also. Now, e is one of the constants what we use in calculus, like especially in the natural calculus, we use e value. All right. Now, when I say natural calculus, don't think that, okay, it's another type of calculus or anything. It's not. The, the parameters what we use in calculus are generally what we use for natural logarithm. All right. Anyway, I'm using big words. Basically, in layman terms, what we have is whenever we have e, e is a constant just like pi. Pi has a value 3.141 something something. Likewise, e also has a value. E value is 2.7182128 dot. This is also a non-recurring, non-terminating number. Basically, it's an irrational number. Alright, just like pi, e is also another type of number. Now what we have, if you have a function f of x as e to the power of x or e raised to x, this is one type of exponential function. There is another type of an exponential function. That is, if you have f of x is equal to a to the power of x. Alright, there are certain things which are very important here. The first one here is a cannot be 0. Because 0 to the power of x is always going to be 0 except when x is equal to 0. So there are certain restrictions what we need to imply on ourselves whenever we are discussing these things. So when you have f of x is equal to a to the power of x, like what we have here, this is also another type of exponential function. Now the difference between e power x and a power x, we can discuss this very easily over a graph. Alright, now let's plot a graph of these two and let's look into it how they're different from each other, or is there any similarity and differences between these two. Alright, let's discuss this over a graph now. What we have right now is you have x and y axis. Now let's talk about the function, first function f of x is equal to say e to the power of x. See, when you have e to the power of x, it's an exponential function. Let's start by taking very simple values. See, say x is equal to 0, then f of x will be equal to 1 because e to the power of 0 is 1. That means we have a point here. And as we know, e power any number is going to keep on increasing. That means the graph is going to go like this. It's going to increase exponentially or drastically. But when you have x value to be negative, then what's going to happen? It will not touch the x-axis, in the sense e to the power of x can never be equal to 0 unless and until x is negative infinity. So a negative infinity is not a point as such, isn't it? So on the x-axis, especially on the negative side of the x-axis, the graph is going to go something like this. See, it's going to be something like this. This is e to the power of x, or f of x is equal to e power x. Suppose if I have next function, see next function, I'll take f of x is equal to a power x. Now, when you have a to the power of x, depending on what the value of a is, like for example, you can have a as 2, 3, minus 1, minus 8, minus 10, whatever it might be. Suppose if you have f of x is equal to a power x, now if you take x as 0, then f of x is equal to 1. Remember, the very first condition is a is not equal to 0. So there is no case of 0 power 0 whatsoever. Any number to the power of 0 is always 1. That means they coincide at this point. Alright? Depending on the value of a. Alright? Again, I'll tell you, depending on the value of a, you can have different types of graphs. Let's assume that a value is 1. See, suppose if a value is 1, 1 to the power of any number is always 1, isn't it? Take 1 power 100, 1 power minus 100, whatever it is. That means here you are going to have a graph like this. It's going to be a straight line parallel to x-axis with a slope of 0. Or if you start changing the value of a, then the graph is going to change. So gradually it can change. It can go like this, and here it can go like this, or it can be a steep curve like this. Here it can go like this, right? Or the graph can go somewhere in between also. That's also possible, in the sense you can have a graph like this, and here you can have the graph like this. But one thing you should notice is every exponential function has one common point, that is x is equal to 0. This is a common point. The reason is, when x is 0, every exponential function, the value of that exponential function will be 1. Understood? Now, this is the basic about what is an exponential function, how the exponential looks like, all right, and the graph of exponential function and everything. Now, in the next video, we'll look into the basics of how do we calculate the derivative of an exponential function. All right. Further on, we can have negative exponential function like e to the power of minus x, e power minus 3x, or 4 to the power of minus 2x. You can have different types of exponential functions, positive and negative. How we are going to look into it and how we are going to differentiate, mainly we are looking at derivatives, correct? So in the next video, we'll look into the derivative of these kind of exponential functions. Alright, so next video, we'll look into the derivative.